We'll go ahead and get started. So just quickly, I'm Christine Wrights. I'm a regional marketing manager here at Planet, primarily working with our US government customers and partners. Justin, you want to give a quick intro?
I would love to. I'm Justin Davis, product manager here at Planet, focused on machine learning, computer vision, AI, all that good stuff.
Love it. Thanks, Justin. So before we get into our road and building change detection capabilities, I want to just share a little bit about Planet. I'm sure maybe all of you know this, but just for a refresher, here at Planet, we are driven by this notion that you can't fix what you can't see. We understand that many of our customers and partners are often tasked with managing a broad area, an often dispersed area, and needing to look at not just what's going on, the activities taking place, but how things change over time. And since Planet was founded in 2010, our mission has remained the same: to image the whole world every day, making change visible, accessible, and actionable. And the way we do that is with our satellites and with what our satellites can do and the power of the data. So real quick, getting into the satellites, I'm just going to talk through our existing constellations. So we have our monitoring product and our tasking product. At the heart of our monitoring product is these planet doves and super doves, also referred to as planet scope. So these doves and super doves are imaging the Earth's landmass and many open water areas every single day. Then on our SkySat constellation is our high resolution tasking product, 50 centimeter resolution. And really the beauty and the power of these two is when you combine it, especially in a tip and queue workflow. So using the doves and the super doves for that broad area monitoring, looking at a large area of interest, and then digging deeper, going into a specific area with our SkySats and tasking, able to delve deeper. Okay, so with these satellites comes a lot of data. So these hundreds of satellites, again, we're collecting data every single day. We have about 2,400 images of every single spot on Earth. And we know that's just way too much to look at with human eyes. And so really the beauty of this data is being able to apply artificial intelligence and machine learning, as we'll get to with this road and building change detection example. And we can use these models that allow you to more easily manage these vast, large amounts of data, allowing you to focus your attention on making more informed decisions. So just to sort of wrap this up with Planet's capabilities, we recently launched the Planet Insights platform earlier this year. So as some of our leaders have put it, if you joined us at an earlier, maybe on the road or some of our events around the Insights platform, our leaders are putting it does the boring stuff so you can focus on your business and what you do best. It consolidates data sets. All of these things we're talking about are different products and the different capabilities into one place, so you don't have to spend time managing multiple systems in multiple locations. So just to, again, before I turn this over to Justin, with our Insights platform, as you'll see throughout this presentation today, you can look broader with PlanetScope, look back in time with Planet Archive, look closer with Planet Tasking, and look deeper with Planet Analytics and Planetary Variables.
First, I wanted to talk through a typical scenario that a lot of our customers go through. So a lot of our customers are responsible for very large areas of land. So for example, here we're looking at a 40,000 square kilometer area in southeast New Mexico. Now, counties there are responsible for knowing what development is taking place and how can they best stay up to date with that. So like we saw, I think it was 25% of folks on this webinar are sending people with boots on the ground. So sending people to these sites to try to keep up to date with what's going on. And this can be really expensive, both from like person hours, but also like gasoline costs a lot of money. Additionally, with this, if let's say you could only visit each site maybe once or twice a year. So at any given time, you might be 6 months or even a year outdated for all of these different sites that you might be responsible for. And then lastly, sometimes people aren't so friendly. People might not want folks checking up on the development that's taking place. So it can actually be pretty dangerous to be doing the boots on the ground techniques. So Planet to the rescue, or other satellite imagery providers. With PlanetScope, though, you get the near daily cadence. So you are always kind of up to date with what's going on the ground from the comfort of your own home and being able to review the satellite imagery on your laptop. And then if there is something of particular interest, you can always task the SkySat to get that 50 centimeter view. But even then, it can be pretty difficult. So for folks that are visually inspecting this data, it can be a lot of data to look at. So for this example of it was about 40,000 square kilometers, there were 2,200 Planescope scenes published. So while the data is there, it can be difficult to keep up to date with. So generally, you're going to need some scale to be able to support all of this data, some imagery expertise in order to analyze it, and ideally some machine learning to be able to sift through it maybe a little bit more efficiently and save some of your eyeballs. And so that's what we've done here. So using computer vision and machine learning, we've created a service that will find where new roads are being developed, new buildings are being constructed. And by fusing these detections with other resources, maybe permit applications or other records, it can be really easy to start surfacing where your attention should be placed. And the New Mexico State Land Office was able to do this to generate an estimated $1 million from permit violations. So, yeah. Now that was for a 40,000 square kilometer AOI. Now imagine doing that for an entire country, maybe the size of Brazil, like 9 million square kilometers of Brazil. And we are doing that as well for a customer there. So really what we're trying to do is make it as easy as possible for our customers and users to stay up to date with massive areas of interest and directing their attention to the places where it's needed so that they don't need to be checking up on every single place that maybe hasn't seen any development. So this brings us to our road and building change detection. And there's a lot of different use cases across many different markets. So for civil government, like we talked about, it could be for permit enforcement, things like that. Maybe protecting areas that need protecting. So rainforests, for example. Defense and intelligence, border monitoring, conflict zones. It can be really good to know where all of the roads and buildings are. For mapping, fairly straightforward. In order to have a good map, you probably need to know where the roads and buildings are. And for NGOs, we've done some really interesting work in population estimation. So using where roads and buildings are and the development of new roads and buildings, there are companies and NGOs that are able to extrapolate what the population estimate could be in very remote areas where maybe there hasn't been a census in decades. So here is a look at, Oklahoma, for example, here. This is our web application. We call it the Analytic Feed Viewer. And it lets you very easily see where development is taking place across very large areas. So on the left here, you can see all of the time periods that were analyzed. So in this case, it's monthly, but we do weekly analyses as well. And then the number is the number of detections that were made in that given month. So with every single detection, there is a confidence score. And that confidence score is an indication of how likely that detection is to be a true positive detection. So up here, you can see we have a filter on this. So if you filter for very high confidence detections, the ones that you look at are most likely going to be true positives. But you may miss some true positive detections that you filtered out with low confidence. But all the ones that you look at will be true positives. If you filter with including low confidence scores, you will get to see all of the changes that were detected or all of the changes that took place, but you'll probably see more false positives. So in this case, we kind of let our users dictate what their tolerance is for false positives. So this is like the broad view. We're looking at like a heat map so that can sort of draw your attention to where the changes are taking place. But what if we want to look at each individual detection and validate that they are correct? Well, we have a flow for that as well, which we will go through here in this little animated GIF. So by clicking this button on the bottom left that says Review and Export Detects, it will show 6 time periods over the same area. And as that loads, so you can see we have the confidence score, and it goes from the highest confidence scores to the lowest confidence scores. You have the location of where the detection was made. On the bottom right square, that's the most recent time period where we made the detection was made, and then it goes back in time. So you can easily see how development is taking place and what was detected. And by clicking on it, it will bring you to the next one. And then you can click on that one, it'll bring you to the next one and the next one. So you can quickly go through this and remove any false positives that you may see so that you can download a clean data set that you could then work with in ArcGIS or any other GIS platform of your choice. Now, if there was a change that you thought was particularly interesting, you may want to task a high-res image of it. So by clicking on a single button, it'll take you to the tasking dashboard where you can give it a name, hit another button, and ultimately when we get there, task a SkySat to get a 50 centimeter view of that same area. So that's how our analytic feed viewer works and how it's integrated with our tasking. But of course, it is powered by an API that you would have access to as well. So if you wanted to integrate it into your own platforms or into your own applications, definitely possible of doing so. It does adhere to the OGC features API spec. So it is integratable with, your GIS platform of choice, ArcGIS, QGIS, what have you. So I wanted to talk a little bit about how we did this. So first, it is powered by a semantic segmentation model that provides a probability score for every single pixel to say, is it a building, is it a road, or is it neither? So here you can see roads in red, you can see buildings in green, and you can see neither in blue. And so the model runs on all of the imagery that's published over a given week or month, and then we aggregate those results into one layer. So from there, we may have, let's say, 52 weeks of results that we could look at for a given year. And that's what we're looking at here. You can see how it kind of changes through time. And by tracking those pixel values through time, it becomes very clear where new building development is taking place. So in this line graph here, you can see the green bar is for buildings, and the probability goes way up here and then goes back down. I'm gonna let that run again so that we can see the building appearing and then disappearing right underneath this stadium here. So if you look right here, you might have seen it the first time, but just in case, let's do this again. So as it goes through time, you can see this building pop up and then pop down. And this was particularly interesting. So we tasked the SkySat and got a closer look. So here you can see this is what it looks like in PlanetScope. We hit that button, we tasked the SkySat, and we were able to get the 50 centimeter view where you can see that this was most likely a big tent that was probably set up during an event and then taken back down. So what's new? I've talked about roads and buildings change detection many times, but this time I'm actually very excited because we have made some significant improvements to that segmentation model that powers the whole service. So for the road class, the F1 score is now 0.72, which is a 70% improvement over the previous model. So F1 is a blended average between precision and recall. So precision is a measurement of, out of all of the detections, how many of them were true positives. Recall is, out of all of the changes, how many did we detect? And so this kind of strikes a balance between those two. So the road F1 is now at 0.72, which is a 70% improvement. The building F1 is at 0.81, which is a 60% improvement. So across the board, it is much, much higher performing than it has been in the past. And the way that we were able to do this is by really expanding the training data that we use to train this model. So here you can kind of see the previous model was trained with the green data sets, and the new one is with the red. So you can see we have significantly more data points. It is significantly more geographically dispersed. And if it's tough to see that, I thought it was too, so I'd have another slide to show in more detail here. So with this higher performing model, what it means is we get much cleaner signal. So here you're kind of seeing the muddled signal from the previous model, and then what it looks like with the new model. So with the previous model, there was signal that a new road had been developed in this example, but it kind of was muddled. It was tough to say. And so sometimes it would be a little tough to really have high performance of the change detections. But with the new model, we're getting much clearer signal where it's very clear that this is a significant change that has a high probability of being a new road. So some key use cases. First, permit enforcement. We kind of covered this, but it is a very it is one that's resonating quite a bit to help counties stay up to date with where development is taking place and really driving some revenue for those counties. The next, similarly, county assessors. So making sure that the valuations of these buildings and of these cities are up to date. And lastly, deforestation. So when deforestation takes place, most often there will be a road that gets developed first to make it easier to bring equipment in, make it easier to bring logs out. So here's just one example where we detected this new road coming in. And then over the course of the next 3 months, this large area was harvested. So this may be an example of completely, above the board deforestation and not maybe not illegal, but it really exemplifies how road development will be a good indication of more changes to come. And I think we are now going to open it up to questions.
Yes, thanks so much, Christine and Justin. Really great to hear about all these new capabilities and the improvements on the products. And we did get quite a few questions. So I say let's just dive in and go a little bit deeper. Let's kick it off here with kind of a common question we got for this webinar and most webinars. People want to know, how much does this thing cost? Is it free?
Yeah. So it is, well, first I'll talk about the packaging. So we bundle it with the visual base map of the same cadence. So this is offered on a monthly basis and a weekly basis. So for a monthly road change detection, it would be bundled with our monthly visual base map. And that's just so that our customers and users would be able to see the detections or what's being detected. Otherwise, there wouldn't be any way to really validate it. So we bundle it with the visual base map, and it costs an extra $1 per square kilometer per year for each analytic. So if you wanted to add road change detection, it would be a plus $1. If you wanted to add road and building change detection, it would be plus $2 per square kilometer per year. And depending on how large of an area you're analyzing, there would be discounts that could be associated.
Thanks, Justin. Zach is wondering if you could show that change detection slide, wow, tongue twister, with the GIF and the line graph again.
I absolutely can.
Great.
If I can find that, I think we're here. Hopefully I'm showing the right thing. All right, let's see here. Probably this one, I think.
With this one, Zach, let me know. And then I'll move to the next question here. Kind of a few questions about where does this work best and where does it have trouble. Mike is also curious. He's from my home state, Alaska. He wants to know about snow cover and if that causes any issues.
Oh, it does. Okay, so this is a fantastic question. In terms of geographic regions and terrains, as you saw with the training data set and how dispersed it is, there isn't too many things that trip it up for like specific countries or areas or types of things, but snow is a problem for our building change detection. Little patchy snow looks remarkably like little building development taking place. We have a few techniques that we use to try to combat it, where basically if an entire city pops up in a given week, we are fairly certain that didn't happen and it will just be like a lot of snow cover. So in those cases, we will kind of ignore or disregard when there's such a large amount of development out of nowhere. But snow does cause a problem, especially for the building change detection. Other things that can cause some issues, there are some agricultural artifacts, I'll call them. So for road development, there can be times when parts of fields will be tilled and it looks remarkably like a dirt road. That will get detected. And there are times when a lake is kind of drying up or a river is drying up a little bit, and it just creates this little path between the water and whatever was there before that looks as well remarkably like a dirt road. So those are kind of some of the key failure modes that we'll see for the road change. Yeah.
Great. Sorry, I'm trying to field all these questions. Juan is curious when this improvement became available.
Yeah, earlier this year. So I think we put it into production in April.
Great.
Yeah.
And
so if you've tried before, it may be worth trying again.
Definitely. Yeah. Continuous improvements. The name of the
Indeed.
game here. Another question here. How often can you run this?
So it's run on either a weekly or monthly basis. So when we set you up with the trial, or when you set up with a contract, we would just set it up to be running every single week, so that you would have those results available for you to query as soon as possible.
Great, really common cadence.
Yeah.
And then from Fernando, is it possible to use this tool or collection in Google Earth Engine?
So it is possible to pull the detections into Google Earth Engine through the OGC feature spec. So the same way that you can pull like WMTS or WFS integrations, this would be supported the same way.
Thanks. And a follow-up here from Zach. He said, you might have covered this, but are you able to trigger an alert when a change is detected so you know when to task?
Yeah, so I guess it depends on what we mean by alerts. So like the detection itself would be generated on a weekly basis. So generally it'll run pretty much on Mondays. So on Monday you could expect new detections to be appearing. Um, and then you could automatically we actually do this in a couple areas where we will take the top 20 change detections by confidence score. So we'll take like the highest confidence scores change detections that were generated and automatically task SkySat, so that we just are always making sure that we have the most relevant high resolution data available. So it wouldn't be an alert like as soon as a new building is created on like a Thursday, for example, it would be there, but it would always be available on those Mondays.
Right. And I think we have time for a few more here. We had a couple questions curious about the size limitations or for like smaller buildings or non-tarmac roads.
Hmm.
Can you tell us a little bit about any of those
Yeah.
limitations?
So talking about the roads, we have a very broad definition of what a road is, because we want to make sure that it could be able to support as many different users or use cases as possible. So it's really anything that you could see a truck driving on safely. So it does include dirt roads. It includes, so it doesn't have to just be paved roads. Anything that a truck could drive safely on would be included. In terms of the size, it can vary a little bit because it's a combination of signal and size. So there are times when there are like single pixels or just a couple pixels that are extremely obviously now buildings or extremely obviously now roads, and those will trigger changes. Or there could be cases where there's a couple pixels, there are many pixels that have a small signal that it is now a new road or building. And so but generally, I would say 2 or 3 pixels. So maybe 20 square meters, 25 square meters is probably a safe bet for a minimum.
Right. Thanks, Justin. I think I got most of the questions that were asked repeatedly, at least. I know there might be a few lingering. So if you have more questions, please do reach out to your customer success manager or use that contact sales page that is linked in the resources. And I will steal the screen share from you, Justin, if
Oh
that's
yeah.
okay. And I have just a few things to share with you guys before I let you go. All right. Oh, there we go. Okay, folks. So if you didn't get the road and building change detection data sheet in the resources, it's available here with this QR code. I really recommend you check it out. You can get more information on the product, especially those important details on how it works. And you can totally share this with your team, your colleagues. Please feel free to share it out. Um, and then, as I mentioned before, this webinar is part of our Agile EO series. We have a backlog of about, I think, 15 or 16 webinars at this point. So if you're curious about Planet products, you need a refresher, you want to deep dive on anything, we have that whole collection available to you. So definitely check out our archive. And lastly, thanks so much for joining us. We will be back in August, and I will send all of you folks an invitation. So keep your eyes peeled for an email in your inbox for that. And then before I let you go, when this webinar closes out, a little survey is going to pop up. It should take 30 seconds, a minute max. So if you could fill that out, we'd totally appreciate it. I'd love to hear what you thought of this presentation and also what you're interested in seeing in the future. We read all the responses and take them into account. So I totally appreciate it. And then a big thank you to Christine and Justin. Thanks for your time and your expertise here. And thank you to all of you for joining us. And we hope to see you next month. Have a good one.